Okay, did you find out what is behind the SPARQL query? So again, this is a public endpoint and there are various restrictions on, for example, the amount of data you can retrieve, the complexity of the queries and so on. So for example, when you try to run a query that would return too much data, it will limit you in terms of both amount of data and processing time needed to process the query. So these are not restrictions of SPARQL itself. It also doesn't mean that your query was wrong. It's just because it's a public endpoint, anybody can connect. They place certain limits on both the runtime and the space amount of data that you can retrieve using the query. Obviously, if you have your own SPARQL engine, your own endpoint, then you don't have this limitation. You're just limited by the processing power of your server. So the next SPARQL query is probably the most important and the most widely used one. It's the one they've seen before in the beginning. It's the select statement. So you want to retrieve triples from a graph that match a certain pattern that you give. So the patterns are, like you've seen before, specified just like an RDF triple, subject, predicate, object. But each of them can be a variable. So now you basically match these triples against the graph, and wherever they match, this is a triple that will be returned. So a select query must have the select query, the select keyword. Now that's the mandatory part. Like you have seen on the worksheet, you can have prefix definitions. You can say what you want to select from. I'll talk about this a bit later when we come to the protocol. And then the actual patterns, like you've seen before, you define in a where clause. So here you have a set of patterns, each pattern matching subject, predicate, object. And at the end, you have a period to show the next pattern. And then you can have a number of query modifiers. Some of them I'll talk about a bit later. For example, you can limit the number of results or order the results. So essentially what we do, looking at it graphically, we have our graph here. Then using the triple pattern, we are matching a part of the graph. These are the triples that we get here. And then using select, we pick out some of these variables that we are interested in our answer. A few details, what you can do with select, you can use select distinct. Often you get redundant triples, and if you're only interested in a unique set, you can filter out the redundant ones with a select distinct clause. You can use order by to sort them. We'll have an exercise on this on the worksheet later, but very often you want to order by something, for example, by amount, by value. You want to sort it alphabetically or something like this. So this you can do with order by. You can put on a limit of the number of results. You can imagine in a large knowledge graph, you could possibly have hundreds or thousands or millions of results. And for very often for practical purposes or for processing purposes, you want to restrict them. If you're talking to a user, you don't want to give a user 100,000 results. Maybe you want to give the top 10. And again, somewhat similar to SQL, there is a whole range of built-in functions that you can use. For example, you can get the minimum, the maximum, a count, a sum, an average of the results. So for example, if you have a number of amounts, let's say a weight or a price, then you can find out the maximum of this amount using the max function. So it's time to try this out yourself on the worksheet, task number 6. You already have the outline given here, but now you have to write the query yourself. And your job is to find all the predicates and objects with Concordia University as the subject. So DBpedia resource is already defined as a prefix, but you have to find predicate and object. So you need variables here, and then you need a matching triple pattern down here. So you can try it out again on the online DBpedia endpoint. And if you have a syntax error, it will tell you, and you'll see what's wrong and hopefully fix it. Good luck with that, and I will see you in the next lecture part.